Welcome to Dev Trends on the Go. Today's Qiita picks for August 10th, 2026.
Yeah, perfect for your commute or, just while you're multitasking.
Exactly. And for our listeners tuning in from outside of Japan, we're looking at sources from Qiita today.
Right, which is basically the Japanese developer community's version of Dev.to or Medium.
Yeah, it's Japan's most popular knowledge-sharing platform for software engineers.
So looking at what's trending there gives us a really sharp perspective on global technical shifts.
It really does. But before we get into today's topics, just a quick reminder.
Oh, yeah. Please hit that subscribe button and leave a like wherever you're listening.
It really helps us keep the show growing.
Yeah, we bring you these developer insights every single day, so your support means a lot.
Thanks for that. So today's sources are taking us on this fascinating journey through the evolving role of the engineer.
Which is, a massive topic right now.
It is.
Yeah.
We're starting with raw database design and some brand new AI features. Then we're moving into how AI workflows are fundamentally changing how we build.
And finally, what this actually means for a developer's career and value today.
Exactly. So let's start with databases. Specifically, a major update that just dropped on August 5th.
The DynamoDB update.
Right.
Yeah.
AWS announced that DynamoDB now supports real-time vector search.
Oh, wow.
But to understand why this is such a huge deal for back-end engineers, we need to talk about how DynamoDB handles data under the hood.
Okay, yeah. Because it's not like a standard relational database.
Right. It relies on single-table design and this concept of access pattern-first thinking.
Which, as an early career dev, always tripped me up.
It's a big shift. In a traditional relational database like PostgreSQL or MySQL, you normalize your data.
To avoid duplication, right.
Exactly. You have a dedicated user table, a separate orders table, and a separate products table.
And then you just join them together when you need them.
Right. When a user wants their order history, the database runs a join-on operation, stitching all that data together on the fly.
Which I guess keeps the storage neat, but, well, joins are heavy, right?
Super heavy.
Yeah.
As your user base scales up to millions, those joins become a massive performance bottleneck.
So how does DynamoDB fix that?
It takes the complete opposite approach. It's a NoSQL database built for single-digit millisecond latency at any scale.
Any scale.
Any scale.
Yeah.
But to keep that speed, joins are basically considered an anti-pattern.
Oh, I see.
Instead, you use single-table design. You put your users, orders, and inventory all in one single table by overloading the partition key and sort key.
Overloading them.
Yeah, you essentially pre-join the data based on exactly how the client application is going to ask for it.
Okay, wait. So it's like, is it like a bento box?
A bento box.
Yeah, like instead of keeping your rice, your fish, and your pickles on separate pantry shelves like a relational database,
Right.
you pack everything perfectly together into one single container for one specific meal.
That is actually a perfect analogy. You're formatting the data exactly how it will be consumed.
Okay, that makes sense. But what if I need to query it differently later?
That's where indexes come in. You have the GSI, the Global Secondary Index.
Which does what?
It's highly flexible. You can add or delete it any time. But because DynamoDB replicates your data across physical servers in the background, a GSI updates with a tiny delay.
Oh, so it's not instantly accurate.
Right. It's called eventual consistency. Fine for a profile picture update, but terrible for a financial transaction.
Yeah, you don't want eventual consistency on your bank balance.
Exactly. So then you have the LSI, the Local Secondary Index.
Right.
It shares the exact same physical partition as your main data. So
Yeah.
you get strong consistency. It's instantly accurate.
No, nice.
But the catch is you are permanently locked into that index structure from the moment you create the table.
Oh, wow. So you can't change your mind later.
Nope. So we've had GSIs and LSIs for years, but now AWS just introduced vector indexes.
Okay, this is the AI part.
Yes, it lets you store vector embeddings right alongside your normal application data.
And how big do these get?
It maxes out at 4,096 dimensions using a 32-bit float. And it's super cheap, like under $1 for small tests using a pay-per-request model.
Wait. Let me push back here for a second.
Sure.
DynamoDB has, like, a hard 400 kilobyte item limit, right?
It does.
So if I'm building an AI search for a video platform, I can't just throw my gigabytes of cat videos in there for the AI to search. The math just doesn't work.
No, you absolutely cannot. And that's exactly where a lot of developers get confused with AI search architecture.
So where do the videos go?
You don't store the actual media file in the database.
Yeah.
The storage is totally decoupled from the search mechanism.
Oh, I see.
You take your source video, you run it through a multimodal embedding model like Amazon Bedrock's Titan or Nova models, and generate the vector.
Okay, wait. I know we say vector search a lot, but for someone who hasn't built this, what does that actually look like?
Like the math part.
Yeah, how does the database know a video of a cat matches the text, funny orange cat?
Think of a vector as just a single coordinate plotted on a massive, multidimensional graph.
So not just X and Y.
Right, we're talking up to 4,096 axes. They represent abstract concepts, lighting, fur texture, subject matter.
Okay.
The AI model plots your video as one dot on that crazy graph. We store just that mathematical coordinate in DynamoDB.
And the actual heavy MP4 file?
That stays over in Amazon S3.
Ah, okay. So then what happens when I search?
When you type funny orange cat, the system turns your text into a new vector, plots it on that same graph, and uses a distance function.
Like measuring how close the dots are.
Exactly. Usually cosine similarity, which just measures the angle between the 2 points. Smaller angle means they're closer in meaning.
And then it just returns the S3 link to the video.
Exactly. DynamoDB finds the nearest vector, grabs the metadata, and hands you the S3 link.
Wow. So for backend engineers, this is huge.
It really is. If your app data is already in DynamoDB, you can just bolt on AI search natively.
Without having to spin up a totally separate, dedicated vector database and keep them synced.
Precisely. It saves a massive operational headache.
That's awesome. But, if databases are searching themselves now, it kind of changes what we're actually coding day to day.
It really does. Which leads perfectly into our second trending article.
Yeah.
There's this highly analytical piece on Qiita by an engineer going by Sumu.
Oh, I saw this one trending.
Yeah, they detail how our interaction with AI has evolved in 4 distinct stages just over the last 6 months.
6 months? That's crazy fast.
I know. They call the stages prompt, context, harness, and loop engineering.
Okay, let's break those down. Prompt is stage 1, right?
Yeah, prompt engineering is the baseline. It's literally just how you ask the question.
Like saying, hey, ChatGPT, act as a senior React developer.
Exactly. It was the Wild West of just asking politely and tweaking your phrasing.
Right.
Stage 2 is context engineering. This is realizing the AI needs background reading before it answers.
Oh, so this is RAG, right? Retrieval Augmented Generation.
Spot on.
Yeah.
RAG just means letting the AI read your specific reference material, like your proprietary API docs, before it answers.
So it actually knows your system instead of just hallucinating facts.
Exactly. It anchors it to reality. But stage 3 is where it gets really mechanical. Harness engineering.
Okay, harness engineering. I was thinking about this word. A harness is literally like horse tack, right?
Yeah, the gear you use to direct the power.
So it's not about making the AI smarter. It's kind of like setting up the ultimate kitchen for a robot chef.
I love that. Tell me more.
Like, you aren't teaching the robot chef how to cook. You're just putting the knives, the recipes, and the ingredients in exact locations so it doesn't accidentally use salt instead of sugar.
That is perfectly mapped to the IDE environment.
Oh, really?
Yeah. Building a harness means giving the language model safe access to compilers, testing frameworks, and error logs.
Oh, so it can actually do the work.
Right. Back in February, OpenAI showed an agent writing 1 million lines of code with 0 human typing.
I remember that. It was wild.
But it didn't do that because the model was magically 1 million times smarter. It did it because they built an incredible harness.
So the AI could just execute the code, read the failure logs, and fix it entirely on its own.
Exactly. The human's job shifted from giving instructions to building the mechanism.
Which brings us to the 4th stage, right? Loop engineering.
Yes. Loop engineering is where the AI checks and fixes its own work automatically inside that harness.
Wait.
Yeah.
If the AI writes a function and then writes the test for the function and then fixes its own code to pass that test.
I see where you're going with this.
Isn't it just grading its own homework? Like, a flawed AI could write a bad test that passes a bad function.
That is the exact vulnerability of the system.
Right. It's just a closed loop of bad logic.
And if you leave it completely unsupervised, it will eventually optimize for the wrong outcome.
So what's the fix?
This is why the author believes test-driven development, TDD, is going to see a massive resurgence.
Oh, interesting.
The human developer has to write the failing test first. You firmly establish the business logic and the success criteria.
I get it. So the human defines the what and the why, and the AI loop just iterates on the how.
Exactly. And honestly, that addresses the existential dread a lot of developers are feeling right now.
Oh, yeah, are we going to be out of a job fear?
Right. The author realized that even if an AI can do 100% of the technical polish and generate bug-free syntax, it's operating in a vacuum. Content or software without a human perspective, an opinion, or business context is just boring. It's sterile.
It might compile perfectly, but it lacks a soul.
Exactly. It doesn't know why the feature needs to exist.
Yeah.
So our unique value is moving away from syntax generation.
Right. Memorizing React boilerplate is no longer the flex it used to be.
The true moat is system design, human curation, and defining those success criteria.
Okay, but, and this leads into our last article today, if syntax generation isn't the bottleneck anymore, and system design requires like years of architectural experience, what is a junior developer supposed to do?
That is the million-dollar question.
Like, how do I actually provide value to my team if the AI can write better syntax than I can?
That exact anxiety is why this final Qiita article resonated so heavily. It's aimed directly at early career devs.
What's the main takeaway?
It argues that technical skills are actually secondary to a customer-first mindset and proactive behavior.
Customer first.
Yeah. And just to give our global listeners context, this is deeply rooted in Japanese tech training culture.
Right. Professional ethics and a strict focus on the end user are heavily emphasized over there as the true foundation of engineering.
Exactly. It's not just about the code.
Okay, I see how that sounds great in theory, but I struggle with that in practice.
How so?
Well, how can I be customer first if I'm still fighting to write a basic API route?
It can feel disconnected.
Yeah, if my syntax is bad, focusing on the customer just feels like empty corporate jargon.
I hear that.
But actually, wait, I guess it's like being a brand new waiter at a fancy restaurant.
Ooh, I like this. Go on.
Like, you might not know how to cook the signature dish yet. You might not know the entire wine list.
Right.
But you can still provide incredible service by paying attention to the diners, refilling their water, and learning the menu as fast as you can.
That is exactly the dynamic playing out in modern dev teams right now.
Really?
Yes. Knowledge and experience are just tools to serve the customer. You don't need 10 years of engineering experience to show empathy.
Okay, but what does that look like on a Tuesday afternoon during a code review?
Well, imagine a junior engineer writes a kind of clunky feature.
Okay.
But in the pull request, they ask, hey, will this loading state frustrate the user on a slow mobile connection?
Oh, wow.
Right. They just fundamentally changed the team's focus.
They shifted the conversation away from just the technical implementation and back to the human experience.
Exactly. And approaching your work that way actually cures a lot of imposter syndrome.
Oh, I bet. Because you're not just staring at your own insecurities.
Right? You're not worrying about what you don't know. You redirect that energy outward to service, asking what the user actually needs.
And that has to change the whole culture of the team.
Completely. A junior engineer can make up for a lack of experience by just aggressively acquiring knowledge and taking proactive action.
Even if they mess up.
Fully expecting to fail. You're going to write bad code. You're going to break the build.
Good to know.
But if you do it while actively trying to solve a real user problem, senior engineers will bend over backwards to mentor you.
Right, because they'd much rather review messy code from someone who actually cares about the product's impact.
Exactly. Way more than perfect syntax from a lone wolf developer who doesn't care about the user at all.
Yeah, that makes total sense.
So bringing this all together, we covered a ton of ground today.
We really did.
We started by looking at how DynamoDB bento boxes are optimizing for real-time vector search.
And then building those robot chef kitchens for AI tools through harness and loop engineering.
And we wrapped up by establishing that whether you are a senior architect or a brand new junior dev, your true moat is serving the end user with genuine care.
The tech is scaling so fast, but the human element is what actually gives the whole system purpose.
Extremely well said.
Real quick before we go, just one last reminder to subscribe and like wherever you're listening. We've got a brand new set of trends waiting for you tomorrow.
And to leave you with a final thought to mull over.
Yeah.
We spent all this time today talking about automating databases and building self-correcting AI loops.
Right.
But notice how every single topic ultimately looped back to human empathy.
Oh, yeah.
As AI successfully handles the how of coding, the why becomes the most critical engineering skill you can cultivate.
That's a really good point.
Will the next most in-demand programming language just be human empathy? Something to think about on your commute.
Have a great day and happy coding.